Okay, now we reach chapter 2. In chapter 1, we talk about hotness and coldness, what we use to measure different temperature. But in physics, we have to go deeper. We have to ask questions behind. Why is that? Why is this? Okay, so when we say something is this temperature, why? When we feel something is hot, why? And everything is about internal energy. Internal energy means the energy carried in something. And indeed, everything have carry internal energy. Okay, for example, in these 2 cups of water, they look identical. Okay, they look very much the same. However, it states that in the textbook they have the same mass but different temperature. We just cannot see the temperature, right? So which one have more energy? Of course, the hot water have more energy, but why do you know that? Okay, if you immerse your finger inside the hot water, you will feel hot because energy flow from the hot water to your finger. You feel the hotness, okay? But if you immerse your finger inside the cold water, energy go from your finger to the cup, to the cup of water. Okay, this is the energy flowing away from your body, so you feel cold. Okay, so actually these 2 cups of water have different energy level. And indeed, if we want to explain this in further detail, we will have to go smaller. Smaller by meaning the microscopic level. Everything is made up of molecules. Okay, you know that. For example, if you have a battery, there are iron, there are different metal molecules. They make up of things, elements, molecules, so and so. And in this chapter, we are particularly interested in 2 things: their arrangement and their movements. Okay, arrangements define their state: ice, water, or steam. Okay, and when we observe them, we can explain why at different states they have different arrangement, different level of potential energy, whether the molecule is far apart or very close together. The energy level is different. Okay, the second thing is movement. Movement in molecular level is how fast or slow does the molecule move around. If it moves slowly, it means the kinetic energy is small. If it moves very fast, it means the kinetic energy is very large. Okay, and actually, these 2 things, arrangement and movement, determine the internal energy an object have. Okay, so let's go to the next page. Here you can see solid, liquid, and gas, 3 states we all are very familiar with. But here you see the table, there are some highlights of some properties of this matter from different states. Okay, for solid, liquid, and gas, when we observe the arrangement, can they move freely? Can they move next to each other? Or do they have to sit properly and stably and do not move at all? For gas, of course, they can move freely at very high speed. If your friend fart, and then you can smell it far away, because the air molecules can flow to different places very freely. But if you put a mouse on the table, you would not expect the mouse run away, right? So not only the object, we are talking about the molecule inside. If you have a look at this solid, indeed each molecule can still have their molecular movement. For example, this molecule, it can still move, but it is only vibration. No matter how it moves, it always go back to this center point. Okay, it can move. It is like you are sitting in a classroom. You can raise your hand, you can put down your hand, you can move around, but you always sit in this chair. Okay, but for liquid, it is more like an classroom activity. You can leave your seat, you can go to find your group mates and talk together about the activity you have to do. You can move around, but still inside the classroom. You cannot go away wherever you want, okay? And for guests, this is like you can go home, or you can go to the playground, you can go to play football, you can go eat desserts, okay? These are the analogy to let you imagine how freely they can move. For liquid and gas, they can move freely. For solid, it can only vibrate about a fixed position. That is what it means, okay? And why do we say that liquid is not as freely as the gas? Is because the shape, it is bound by the gravity, 地心吸力. And although the water molecule can flow up and flow down, however, the overall collection of the water molecule will have to stay together. Okay, this is about the arrangement, how freely they can move. Okay, and then let's have a look at the shape and volume. If you have this alarm clock, oh, it's blue, you cannot see it. Okay, if you have something solid, then the shape and volume will be fixed. You cannot change it easily. But for a cup of water, you can put it into a bowl and the shape of the water arrangement is changed. So here for, okay, I have used blue for fixed. Okay, for solid, both volume and shape is fixed. And for liquid, the volume is fixed because at 100 ml, you pour it into another container, it is still 100 ml. The volume is fixed, but the shape is not. The shape is free to change for liquid. And for gas, both volume and shape can change freely. For example, for gas, if I blow a balloon and then I tie the balloon together, okay, you have a balloon, but you can still squeeze the balloon to be smaller, or it can get bigger, and the volume can change dynamically. Okay, so for gas, both the volume and shape is free to change. Okay, and then for the molecular arrangement, the most important key point is that this is closely packed for both solid and liquid, because the molecule, they have an attraction force and they are held together very packed. They have to be very close to each other. Everyone is inside the classroom and very packed. Okay, I cannot think of a better analogy yet, which is this one is not so good for now. And however, for gas, they can be very far apart. I want to use different color. Let's use yellow. Okay, they can be very far apart. Gas molecule, they do not have to be near each other. And the position is not fixed. Well, I would say no fixed shape is related to this not fixed position. Okay, but this one, since it has a fixed shape, so it has a fixed position. Okay, then in this table you will know some properties, differences or similarities among these three states. 三個狀態 solid, liquid and gas, these three states. Okay, so in general you can see the bottom part, it is more yellowish in color, which means it can move freely. They have very high speed, and they do not have fixed shape because they are less closely together or packed. Okay, this is the impression you would get after studying this table, and I would expect you to be able to fill in the properties if this table is empty, and you will have to compare them. Okay, so what do we know about them? Molecular kinetic energy. So when we talk about internal energy just now, there is indeed two parts.